What's up, guys? Welcome back to the channel. As you can see, I have Orangina behind me, my 1980 Vespa Primavera 125 that I've restored from the ground up. Pretty much every single piece, nut and bolt on her is brand new. The engine also fully rebuilt. So if you guys haven't seen the test ride video I did on her, make sure to check that out. So my buddy Rick saw that video and has requested that I build an engine similar to what's in her. Pretty much all brand new pieces, and main difference is that he will be using the SIP Smallframe case. I know there are different versions of this case, so if you decide to do a project like this, make sure you do your research. Okay, this one is the most similar to what's in Orangina, so that's what we're going to be using. So yeah, if you guys are ready, let's get to it. The first thing I'm going to do is remove these rubber engine bushings, because Rick has opted for these fancy Cloth Studio ones, and also because we're going to be putting the case in the oven and cooking it and expanding the actual metal so that the bearings will drop in easier. I'm also going to cook this inner race on the fly side bearing as well, because this goes over the crank like that. And then for this stuff over here, the bearings and the crank, I'm going to put in the freezer so they actually shrink a little bit. So I'm going to expand this case and shrink these parts, and hopefully they should just fall together without too much effort. Okay, I just got this cases separated. Is these two bolts that it ships with. Now this case doesn't come with the actual case bolts, so you got to order that kit separately. All right, so I'm gonna press these bushings out. That way we can put this thing in the oven. You don't usually do it like this, but whatever works, I guess, right? So yeah, I kind of pushed this socket over the actual rubber bushing, and then just kind of pulled this out pretty easily. All right. All right, one last one. All right, pretty painless. All right, so you can see I got all the engine bushings out, kickstart buffers. So yeah, next step, I'm gonna stick these in the oven for I think 15 minutes at 250 degrees. And that should expand the cases enough for me to just drop the bearings in, hopefully. And after that's all done, then I'll put these new bushings in. I'm actually going to expand this as well because it's going over the crank. All right, so I have the crank out of the freezer. I have my wedge in here, 1mm spacer, and then I have this inner race of the flat side bearing fresh out of the oven. So I should be able to just drop this into it. It doesn't always work, but you can tap that on gently. Okay. Whenever you tap anything on the crank, make sure you have a wedge here. The 1mm spacer is so that I can remove that inner race later if I have to. So this thing is good to go. Now we can move on to actually putting the bearings in the case. Okay, so I have this case half out of the oven, these bearings out of the freezer. This is the fly side outer bearing. Hopefully it'll just drop right in. And of course it doesn't. So I'm gonna tap that guy in. Okay, so that went in. Got this guy back here. Sorry, I had to go on the floor because people are sleeping in the house. All right, one more. Okay, I think this is good. All right, have the clutch side bearing. Hopefully this drops right in. If not, we're gonna be in trouble. You don't want to keep banging this stuff. Yep, nope, I gotta bang it in. Dang it. Okay, not too bad. The last thing is going to be the hub bearing. This one's usually pretty easy. Like that. That one dropped in, no problem. Alrighty. It's a little bit of a pain, but that's just how it goes sometimes. Just glad I got all the bearings in, nice and flat. So yeah, we can actually wait for these things to cool down, and then we'll reinstall the engine bushings. Alright, while I'm waiting for these guys to cool down so I can put the engine bushings in, I'll go ahead and reinstall these snap rings. So there's one that goes on this primary bearing. One, and one on the other side for the clutch side bearing, main bearing. Alrighty, that's it. Still a little hot, so I'll wait a little bit before I actually try to install those engine bushings. So yeah, these are good to go. It was a little bit of a pain, as you saw. The cooling and the heating method doesn't always work, so I always have my drifts, you know, ready in case I need to actually knock them in. All right, so now I've got the cases cooled to the touch. I'll go ahead and push these new engine bushings in. It should be pretty easy because these centers come right out. So we'll see how it goes. I know this spacer is in here on this side. It's loose. I don't know why, but it goes in there, so I'm gonna leave it there. So let's see if we can push this guy in. If not, we'll get a little bit of tire paste and maybe that'll help me out. That wasn't bad. Very nice. Okay. Push this one in. These pins in. Okay. Easiest set of bushings I've ever installed. Very cool. All right. Hopefully this will be the same. It looks like this side's beveled, so I'll push it in this way, see if that helps. Okay, I think I got it. Had to put a socket on this end and vise this side in. So looks like it's nice and tight in there now. So all right, good to go. All right, last thing, push a little metal sleeve in there. There you go. Your Klaus Studios bushings installed. Wasn't too bad. Actually, I'm gonna tap this guy in a little bit. Yeah. Perfect. All right, so new product alert. Now, if you guys watch my other videos, you'll notice that I usually assemble my engines in a rotisserie that I can rotate 360 degrees. That's because I do a lot of engines, so I understand that most of you probably won't have something like that. So these are definitely a great alternative. So this is a new design. It's from Scooter Mercado. Dave came up with this, a nice, simple, easy engine stand that you can just throw together real quick. And all you really need is a piece of wood, so you can just screw the points in, and then you have yourself a nice base for working on engines. They work on large frame and small frame. They come raw like this, but I'm probably going to spray paint these so they don't rust. So yeah, if you guys are going to do this once, definitely worth getting a set of these. And they're pretty cheap. I think they're $45 or $50, something like that. So yeah, like I said, if you're going to do this once or do it a lot, definitely pick yourself up a set of these. So anyways, I've got my engine all mounted up. I'm going to go and put some wood screws in these 3 points, and then I should have a nice solid base to work off of. Okay, I got my engine mounted onto the piece of wood. I'm using 2 screws at each point. I'm not doing anything crazy, so this should be fine. So the first thing I'm going to install is the shifter mechanism. This is actually brand new in a bag. And by the way, every single piece down to the last washer or screw is from Scooter Mercado for this build. So yeah, if you got an old frame in the shed and you're looking for an engine, you can definitely get all the stuff you need from Scooter Mercado. But anyways, so yeah, the selector comes out of a bag like this, all assembled. You gotta remove this pin so you can get the selector mechanism off. I'm gonna hammer this off real quick. Oh, it's loose. Okay, so this pin is actually beveled, so it only goes in one way. So take the selector off. Okay, I had to adjust the camera angle. So in the kit, there's 2 O-rings. Make sure you put those on this stem here, and then the washer is separate. So make sure you get one of these. This goes onto this stem here. So let's go ahead and see if this fits okay without any modification. You kind of have to put them both at the same time, sorta. Or there you go, like that. Okay. That. Okay, so the kind of it's supposed to look sort of like that. Okay, a little linkage back here in the case. All right, now on this bolt, this is a special bolt with a washer. Okay, you just put some oil on the top here, in this little cup there, and then we'll thread this bolt from the top of the case. Okay. Now to torque this bolt, it's 18 Newton meters. So let me get back up. Okay, didn't take much. All right, now that I've got this mechanism torqued down, make sure it actually works. Is actually very tight though. Oof. All right. May have to yeah, it's not supposed to be that tight. Okay, I'm gonna have to do something. Maybe remove that washer or grind the top of this selector a little bit. Yeah, that's what I'll do. I'm going to file a little bit of material off this selector arm just so it moves a little freer because that is way too tight. All right, let me do that off camera. Okay, so before you start freaking out that I'm modifying parts, this is actually an OEM selector mechanism. I'm going to compare it with the aftermarket. And it looks like the aftermarket just a smidgen taller. That's probably why it's so tight. But yeah, I'm going to take a little bit of material off the top here with some sandpaper, and that should free it up a little bit. A little bit of material off the top of this shifter mechanism, and I reinstalled it, and it's definitely a lot better than before. Before I can barely move with my fingers. So you don't want this, you want it tight, but not too tight where you can't move it, because then it'd be really hard to shift the gears. So it's still tight because this wave washer on the bottom is actually pushing it up. So just a little bit of material will make a big difference. So all right, now that's done, we're gonna go ahead and reassemble the Kickstart stuff. Oh, and the linkage I'm gonna reinstall later. Once I have the gear stack in there and everything seems to be right, and I'll reinstall this just so I know the orientation of the pin is correct. So keep this in a bag, in a safe place. Okay, so here we're gonna put the Kickstart quadrant in. So in the case there's an O-ring. Now it's in the kit. It's in this kit right here. That O-ring right there goes in that little groove right in that opening. So let me see if I can get this out. I'll show you how that goes. So the biggest O-ring in this pack. All right, so put some grease in there. We can actually grease this O-ring a little bit, make it easier for the installation. And also when you push the actual quadrant in. So work this guy into that groove in there. Hopefully you can see what I'm doing. Okay, just like that, O-ring's in that groove. Let's go back on this side. Put a little bit of grease on this quadrant. Actually, first thing, before we put the quadrant in, you gotta reinstall these little Kickstart buffers. I removed them when I baked the case for the bearings, so that goes there, and this goes here. Now, when you go to rebuild the motor, it's a good idea to go ahead and replace these because it will probably be all hard or either torn. So, all right, now that's in there. I'm going to put the Kickstart quadrant in. Jeez, that's really tight too, but that's okay. I just need some breaking in. I'm going to remove this to make sure I didn't tear the O-ring. And it looks like it's okay. Yeah, just needs a little bit of breaking in. So, reinstall. Well, it's easier the first time. Let me do this again. Make sure I'm not cutting into that O-ring. No, it looks good. It's just new, so all right, let's try again. Okay, there you go. Good. All right, it's already getting a lot smoother. So, all right, put the spring on. The spring should go like this, okay? So we kick it, it goes up and then resets back down. All right, up next, I'm installing the clutch side seal for the crank. This is the part number for it and the specs. So the crank is actually different than your standard small frame crank. This one actually has a 20mm taper. So the seals are a little different, but the clutch side seal is the same as your standard one. The other side, I'm going to show you the part number for that, is a little different. So let's go ahead and put this in. Make sure you oil this up real nice, because it can be a little bit of a pain to get in. All right. Got my drift and my hammer. Hopefully. All All right, notice I had to switch from this to like a socket around the same size because this is actually touching the bearing in there. I noticed it when I was tapping on it, so don't use that. Use a socket. But yeah, as long as the seal lip is flush with the case, you should be good to go. All right, so next up I'll be installing the crank. I was saying the crank is actually different than your standard small frame 125 crank. The taper here is a little bigger. It's 20 millimeters compared to the standard 19 millimeters. So this fly size seal is going to be a little different. This is kind of the stuff that I've had to learn on my own because nobody actually talks about stuff like this. So this crank is a little upgraded. I went ahead and installed the inner race on the fly side bearing. So that's good to go. I left the 1 millimeter spacer here just so the puller can actually remove that later on if I have to. So we'll go ahead and install this. I have my crank puller tool. I have the insert that goes here. So I'll put this on after I place the crank into the case. So let's get that on there. All right. So before I do this, I'm gonna put some oil on this lip here because it helps with sealing against that oil seal. Nice and lubricated here and here. It's important. So all right, once that's done, you can go ahead and push it in. Like that. Now, on this end, when you pull in the crank in, make sure this rod is here in this opening of the cylinder and not here. Because if you pull it and it's resting there, you're going to bend the rod. All right, so now I'll go ahead and put this on the end of the crank. That's good. Push that forward. All right, 2 crescent wrenches, one here. One here. I'm going to turn this. Put a piece of rag here just so that rod doesn't drop down. And we'll slowly turn this nut and it'll slowly pull the crank into the case. Rag is actually keeping the rod from actually touching the case or getting bent by the case. So pay attention to that. And it just bottomed out, so we are good. Okay. Good to go. Make sure this is spinning freely, and it is. Nothing binding up. All right, we can move on to the next step. Alrighty guys, so it's actually 2 months later. Reason being is that I had ordered more parts for this build. And then our rally came up, and then Lammy Jammy, of course, so I've been busy preparing for those two. But now that those events are over and done with, we're back on this build. So, reason being that I had to order new parts is because Rick has opted to go with the E-Gig Performance one-finger clutch, okay? And this is the clutch, part of the clutch here. And originally I had a SIF 2769 primary that was going to go into this bike. I was assuming that the 2769 primary was sort of like the stock basket, but it was not. So when I actually put the little clutch part into the basket, there was rivets or whatnot that got in the way, and this would not spin freely. Okay, so guys, if you wanted to get performance parts for your small frame, it's a very good idea that you get them all from the same manufacturer, because mixing and matching, it's really hit or miss. Some parts will work with each other, some parts will not. So it's either you do your research and hope somebody has actually messed with it before you go and order something from SIP or wherever overseas, because it's very hard to return stuff like that. Luckily, I got the primary from Scooter Mercado, and Dave was happy to take it back. Well, I don't know if he was happy, but he took it back. And he ordered me this one instead. This is actually a E-Gig 2769 primary, and it's actually very, very nice compared to what we were going to use before. Since this is an E-Gig primary and an E-Gig clutch, of course these parts work just fine. Now on my blue badge, I actually have something like this, but it was made by DRT. Now on the DRT primary, the bolts assemble from the front, okay? So I also have the one finger clutch on my blue badge, and when I actually spun this around on the DRT primary, this thing actually hit the little bolts that mounted on the front. So I had to modify the bolts to clear this. And luckily, I was able to make it work because I had already had the DRT primary in the bike, and I wanted a softer clutch, so I ordered the E-Gig one finger. So luckily, I was able to make that work, but that's not always the case. It's like this time when I was using the SIF primary, this did not work with it at all. I could not do anything to modify because of the rivets or whatnot on the SIF primary. But this is the E-Gig one, and this is nice because everything assembles from the back. So that means it keeps the actual basket part clear. So you can really put any clutch on there. So yeah, this goes in, and then you kind of put the springs in from the back, and then kind of bolts from the back. Okay, so it's a very nice piece. Definitely something you should look into if you wanted to get a performance primary / clutch. All right, so yeah, now that I got all the right parts, let's go ahead and continue with this build. Okay, so the primary comes apart for there's a certain reason why the primary comes disassembled from E-Gig, okay? Some cases you cannot actually install this when it's assembled, okay? Like the stock cases. If it came assembled already, you would have to actually go and disassemble it before you actually get it into the case. And I'll show you why. So I'm gonna go ahead and not put the springs in this thing, kind of just assemble this, you know, finger tight, whatnot. And I'll show you why some of these won't fit into the case assembled. I think it does in the SIP case, which is what we're using here, but the factory cases, they do not. So pretend it's assembled, and you try to go and load this into the case. See how I cannot get it to really line up. See, this one you can, okay? I guess this opening here is a little bigger than the stock one, okay? So I can actually assemble this completely and then install it normally. Now, I'm gonna show you how to do it apart, so you can see, just in case it doesn't fit in your casing, I do it separated. So, take this thing apart. This is the foolproof way. Actually assemble it inside the case, and then you'll know. First thing we're going to do is load this part with the springs. Okay, you just get a pair of pliers like this, adjustable one like this. You can actually compress the spring and push it into these little slots here. Okay, just gonna rest them in there like this. Okay. So this is actually the cush drive, okay, in a small frame. Cush drive, primary, yeah, all that stuff is built into this thing. This is actually what cushions the transfer of power when you let off the clutch. This is not on, this is literally on and off, you know, making the bike hard to ride. So, yep, there you go. All 4 springs are in place. Now you're gonna have to leave this guy back here, like so. Okay, now that I have this thing assembled, I'm gonna go ahead and try to slip this into the that bearing right there. So before I do that, I need to heat that up a little bit to expand it. All right, got it nice and warm. Let's go ahead and try to push this in. Okay, nice and easy. It's nice and warm. Okay, now I have the primary gear actually in the bearing, in the case. I'll go ahead and put the basket on. Now, as I mentioned, some cases you cannot actually install this thing unless it's a part. Okay, so for instance, the DRT primaries that come assembled, you actually have to take them apart, which makes no sense at all. You have to take them apart and then reassemble them back into the case. So I don't know why they don't ship it all apart, so you can do the same thing I'm doing here. All right, so I have the basket pushed on temporarily. I'm going to go ahead and flip the case around, and we'll actually install these bolts from the other side. There's a bolt hole there. I'll keep rotating them and put in one by one. Before I do that, I'm going to put some Loctite on these bolts. And then once we have them all kind of finger tightened there, we got to torque them down to 13 Newton meters. Okay, this is kind of important because if this thing comes apart on you, it'll lock the motor up. So make sure you do that. Let's see if I can get these things. There you go. Just do one across from each other first, just so it kind of evens out. Okay, once you actually assemble it, make sure it spins freely. It's kind of snagging up, but I think it's because I don't have the thing tight together yet. So I'll go ahead and tighten them all, and then we'll see if it spins freely. Okay, we got everything finger tight. I'll go ahead and torque these guys down to 13 Newton meters. That's 1, 2, 3, 4. Cheap tools. Okay, now I've got everything all torqued down properly. It spins freely, so we should be good. Okay, now I've got the primary all assembled into the case. Next thing we do is put the shim on. This shim actually comes with a kit, and it's so that it keeps the basket from moving back and forward. And then, of course, the snap ring after that. Perfect, nice and tight. Spin freely, good to go. Okay, next up I'll show you how to put the Kickstart gear in. First, there's a little washer thing here. This is actually what the spring sits on. So install that first. Kind of covers up the bearing a little bit, but make sure that's nice and flush into the opening there, like that. And the spring afterwards, like this. Okay, after that, you put the gear in. Move the Kickstart lever a little bit, and there you go. That's it. This is how you assemble it. Okay, the older ones is a 3-piece spring. So make sure if you take those older ones, you can either replace it with this new style, or keep the older ones in a certain order when you reassemble. All right, so this is good to go. Next up, we'll assemble the transmission and then drop the transmission in the case. Okay, so here I have a brand new ET3 transmission. Okay, brand new gears, brand new output shaft, lay shaft, whatever this is called, brand new cruciform. Now there are different cruciforms. Okay, I've explained this in my other video of me showing how to stack these gears. So since these are ET3 gears, you got to make sure you order the cruciform for the ET3. Okay, it's on the box. It says ET3 right there. Okay, now if you have an older Primavera 125, make sure you order the cruciform for the older Primavera 125. Okay, there is a slight difference. Okay, when I first put together Orangina, I put the Primavera cruciform in with brand new ET3 gears, and yeah, it acted funny, and I was sitting there revving it up, and it kind of jumped into gear on its own and almost fell over. Thank goodness it did not, but I had to pull the motor back out and actually change it to the right cruciform. So make sure you don't make that mistake. If you have new ET3 gears, get the ET3 cruciform. Old Primavera gears, get the Primavera cruciform, okay? All right, so we're going to start with the lay shaft here. I'm going to install the new spring and the two balls, okay? So the spring goes in, and the ball that goes on either side of the output shaft. Okay, so let me put one in this hole here. Put the tool over it like that, and then I'm going to flip it around, and we're going to get the cruciform ready here, like that. Okay, I'm going to push down on to the bench so it holds that other ball in place, and push down here. Push that ball down. And I'm going to push the cruciform over those two balls. Now, I'm doing this out in the open, but it's a good idea that if you're going to do this and you've never done it before, get a clear plastic bag and kind of do it under that. That way, if balls go flying somewhere, you don't have to go looking around your shop for them. So that's how you start. Now, next, you have to put the shim on this side. Put a shim on the side. So I went with the standard shims because I don't know what I may need, and the standard is 1 millimeter. After that, put a snap ring on this side. Come on. That's weird. The snap ring is not going into the groove all the way. All right, so it's actually a couple days later. I just realized that there are different snap ring thicknesses. So the newer lay shafts use the thinner one, which is 1.5 millimeters. The older lay shafts use the 1.7 millimeter snap ring. I didn't want to go ahead and just sand this down because we do have to mess with shims. So I went ahead and ordered the correct ones from Scooter Mercado, and they just showed up today. So now we can continue actually putting this transmission together. So like I said, you put the shim in first after you put in the two balls in the cruciform. Okay, like this. Next is a snap ring. The correct snap ring this time. So there you go. Much better. Okay, now you can actually pull this cruciform down without it popping out and the balls flying everywhere. So now that this is done, I'm going to put it in my vise and we'll go ahead and stack the gears. Here I have the brand new gear stack for a ET3. Okay, so on these gears, every one of them has a taller side. I don't know if you can see that, but see this little ledge right here? That makes it the taller side. Okay, same with this one. Little ledge right here makes it the taller side. Okay, same with this one and this one. Okay, so on a small frame, you have the bigger gear going on the lay shaft first. On the large frame, it's the small gear that goes first. So I have the big gear. This is actually first gear, taller side facing up. This will be second gear, taller side facing up. Third gear, again, taller side facing up. And fourth gear, again, taller side facing up. Okay, just like that. After that, put on the shim. Again, I'm using 1 millimeter shims. I guess that's your standard size. At least that's what Dave at Mercado told me, so we'll try it. we're going to be checking the tolerances between the snap ring and the actual shim, shoulder washer, whatever. But right now, seems like the gears are floating just fine, so it should be okay. I have the cruciform all the way down, so it's locked into first gear. You push it up, that's the neutral position, so you can see I can turn all the gears, okay? Up one more, that would be second gear, so I can't turn second gear, I can turn all the other gears. Up one more. Nope. There you go. Up one more, it'll be third gear. And turn all the other gears besides third. And then the last spot is going to be fourth gear. You see how that works. So that's how it changes gears, if you've always wondered how a small frame transmission works. Alright, so now that I have everything all assembled, everything's spinning freely, and the function checked everything, I'm going to go ahead and check the tolerance between the snap ring and the shim. Hopefully it's not too tight. I think the tolerance is between 0.15 millimeters to 0.40. So I'll grab my smallest feeler gauges and check this real quick. Alright, so I have my two feeler gauges. See, this is 0.15 of a millimeter, or 6/1000ths of an inch. Okay, so I'm gonna put in the gap here, see if I can, yes. Alright, good. That's the minimum tolerance you need. Okay, so the tolerance between here is between 0.15 to 0.40 millimeters. Anything less than 0.15, it may be really hard to shift gears. Anything over 0.40 millimeters, and it might not stay in gear. So make sure you get it within that spec. Next up, we'll put the transmission in, and before you do that, you need to move this primary basket. There's a bigger opening right here. All the other ones are small, so put the bigger opening in line with the actual rear output shaft right here. Okay, so you'll see why in a second. Okay, I have the transmission here. You'll see that you need to do that because leave the opening there in line with the output shaft, because you need to move this around in order to get this cruciform into these paws here coming off the shifter mechanism. I don't know if you can actually see what I'm talking about, but right there. Okay, put those paws in line with the cruciform, and then after that, push it in. Okay, because that paw is actually what moves the cruciform back and forward to change the gears. Okay, now that this is actually resting in there, I will go to the other side and pull it in with my crankshaft puller. Alright, I have my crankshaft puller with the right insert for the output shaft. So we'll thread that guy on first, and then we'll slowly pull the transmission back into the case. Okay, done. That's it. All right, before I actually put the other case half on, I'm going to go ahead and install this cable guide for the gear selector. Okay, so right now the transmission is stuck in first gear, because that's how it had it when I installed it. So I'm going to shift it out of first and hopefully move it all the way to fourth so I can actually install this little mechanism here. So I'm stick a little pin through here and kind of just rotate the gears around. Okay, so that's neutral. Second, third, So I have the cruciform shifted all the way out to 4th gear. That way the hole is easily accessible so that I can put the pin through for this selector. So it should look a little something like, that's not right. There you go, like that. Okay. All right, so you push it up there, make sure the hole is lined up for the pin. So remember I said this pin is beveled, okay? So it only goes in one way correctly. So move this around until it goes in. There you go. All right, now I can go ahead and tap that pin on and actually install it. All right, should be good. So it was stuck in 4th gear. Now turn it this way, it's actually 3rd. Keep going this way, it'll go back to 2nd. You have to rotate the gears separate from the shaft so that these cogs line up. There you go. That's 2nd. Neutral. Yep, neutral. And then, of course, 1st when you shift it all the way over. There you go. 1st. Yep. So back in neutral. We'll leave it that way. All right, so next up, I'm going to lap the Christmas tree. This is the input shaft with the actual clutch here, that connection right there. Okay, obviously 2 different manufacturers. These are the mating surface between here and this taper are not perfect. So to get them perfect, what you need is a valve grinding compound, which is this stuff here. Put a little bit on the end and kind of just sit there and grind it a little bit, and that way actually makes both surfaces perfect for each other. Okay. I did not do this on my blue badge, and I went to replace the clutch with the EGA wind finger. I opened it up, and this thing actually, the key was sheared, but it wasn't broken. Okay, so that just tells me that these 2 mating surfaces are not perfect for each other. So it was able to move when I tightened it together. So make sure you do this if you got a nice high performance build you're doing, because like I said, these 2 surfaces are not perfect for each other. It could come loose and the key can shear. So looking at it now, looks pretty good. A little more. All right, should be good enough. Take a look. I will still use the Woodruff key, of course, but see how it's kind of sanded down a little bit. Same with this surface in here. Yep. Okay, now when I actually install everything together, hopefully this surface here is mated with this surface perfectly. Okay, so next up, I'm going to assemble the case halves together. Now, eGig recommends that you put a 0.5mm shim at the bottom of the input shaft. Okay, this actually pushes this further out, and I guess gives you more thread so you can mount the clutch. So the other thing I'm going to do is put a 0.5mm shim on the end of the Kickstart quadrant right here. Reason being is that I already had this case kind of assembled earlier, and I noticed that with the Kickstart quadrant having a little too much play between the case, just moving around, actually let the Kickstart gear come out a little bit. When that happens, it's actually touching the teeth on the input shaft. So when I was function testing this thing with the case halves together, just cycling the crank manually, it was actually making a clicking noise, like a little click, 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 and that's definitely not normal or not something I've heard before. So yeah, my solution is put a shim here, and hopefully it takes up the play between the case halves, and that solves that problem. Now, if you're wondering where I got the shim kit from. This is actually from SIP. It's made by DRT. Dave at Scooter Mercado ordered this for me. If you're going to go and build yourself a brand new motor, new case, new parts and all that, make sure you order one of these because you may need them. All right, so I've got everything situated. I got the gasket on here. I'm going to slap the cases together again temporarily to see if everything functions okay. If it does, I'll take it apart again and we'll apply sealant to the gasket and then assemble it together permanently. The other thing is, on a SIP case, these studs don't come installed, so you'll have to install these and have them stick out 42 millimeters. Use Loctite so they don't move around. All right, so let's get this case half together and do another function test. Getting a small frame case halves together can be a pain. There's literally like 4 different things that have to line up in order to get the case halves together. So just keep wiggling the crank, wiggle the case clutch basket, wiggle the axle until everything lines up. So I have it all together now, and before, when I was doing this, it was making a clicking noise, like a little light click, 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 click. Now it's not doing it, and I'm guessing it's because I took up the play between the Kickstart quadrant and the case halves. So I think we should be okay. Kickstart works, that's good. Sometimes you put together the case and Kickstart don't work. So again, you gotta go in there and start shimming things to make it all work. So yeah, like I said, this seems to be okay. I'm gonna go ahead and bolt everything together and then we'll check it again, make sure everything's all right. If it is, we're good to go. All right, I'm gonna put some of this former gasket stuff on this gasket here before I install it. I'm doing it on both sides. I typically don't do this, but usually I use grease, but Rick is not down the street from me, so I don't want him to have any leaking problems, just in case. I never actually had any leaking problems using grease, but you never know. All right, stuff smells great, but we're done. Got the gasket coated on both sides. I'll go ahead and install this guy, and we'll put the other case half on. So I noticed on the SIP case, this dowel pin comes like that. You need to knock it in a little bit so it actually matches with the other case half. So get yourself a punch and kind of tap that over a little bit before you put the other case half on. Otherwise, that dowel pin's not being used to line the cases. Okay, like this. All right, now you can actually use that pin to line the gasket up and the case halves up. Let's do a final assembly on this other case half. Okay, looks pretty good. I'm going to tighten some hardware together. Okay, I've got all the hardware finger tight on there. Now, your typical small frame hardware kit doesn't come with every single bolt required for these new late model engine cases, which is what this is. So if you go and order a hardware kit, make sure you order one extra 80mm engine case bolt, okay, because you're gonna need it, because it comes with this one and you need this one. I believe it's this one here that actually needs it. So yeah, make sure you order that. Okay, so now I got everything all tightened down. I'm gonna go ahead and torque everything to 15 Newton meters, and then this part should be done. All right, as you can see, I had this clutch cable guide already installed on the case, but this bolt here actually is one of the case bolts. So make sure you put this thing on at the same time when you're torquing everything down. Next up, we'll be installing the clutch. Okay. Honestly, guys, this video is taking me probably 2 or 3 months to make, because every step of the way this thing's been fighting me. So first was you saw the primary compatibility issue with the E-Gig one finger clutch. So we had to order the E-Gig primary. So second is that you need a special tool to tighten the clutch nut for this setup. And I thought I had it, which is this guy right here. And apparently it's the wrong tool. This is actually made for the HARZ4 clutches. I don't even know what that is, but that's what SIP told me. But luckily, my buddy Rob Capel has the right tool right here. He's kind enough to let me borrow it just for this job. I actually have one on order, so I'll be sure to send this back to him as soon as I'm done with it. So yeah, you need this tool. You need the clutch installation tool. This is by Fabry Racing. If you don't have this, I can show you how to do it with the standard clutch puller, small frame clutch puller. Okay, so first off, you need to install this part of the clutch, the center, I don't know what this is called, but the center part of the clutch. First thing you need to do is install the Woodruff key. And you got to be very careful when you're doing this, because you don't want to drop anything down there. Luckily, the Woodruff key is magnetic, so you may be able to get it with a magnet if you do drop it. But it's a good idea to put a piece of cloth right here or a towel. That way, if you do drop something, it'll catch it. All right, so Woodruff key's there. I'm going to tap it on with a punch. Get it nice and seated. So it's very important that you tighten this guy on here very well. Okay, you saw that I already lapped these two parts together. And then E-Gig recommends that you tighten this clutch nut down to 70 Newton meters, okay? So when you do that, make sure you use a brand new nut. Don't use your old one, okay? Because the threads will deform a little bit when you go to 70 Newton meters. Okay, so I got the Woodruff key in. Now I'll install the inner part of the clutch. There you go. Okay, new wave washer right here. Before I do that, I'm gonna put some Loctite. Like I said, it's very important that this part is tight, solid. On my blue badge, I actually saw this thing. I don't have this kind of setup. It's a DRT setup with the E-Gig one finger, but I saw the Woodruff key actually shear almost break, but it wasn't. It's just, I guess it didn't have the good connection between the two pieces. So again, I don't think I actually tightened it down to 70 Newton meters, but yeah, I had to take that out and fix it and do whatever, torqued it down right. And hopefully it doesn't happen again, but that was on my blue badge. This is a totally different setup. So, all right, so you put the wave washer there, Loctite, nut. Okay, now you can use this tool to hold everything together or keep everything still so you can tighten it. Never used this before, but we'll figure it out together. Like that. Use the biggest opening. That's probably better. Rotate this guy. Okay. There you go. All right, so you see it holds this thing steady. It holds this steady, and then you need a socket to go over the crank nut. We're going to be tightening that thing after this part. So that's that. Now we can tighten the clutch nut. Like I said, it needs to go to 70 Newton meters. And it's already on 70 Newton meters. Okay. Again, brand new. Use a brand new clutch nut. Loctite, new wave washer. Okay. Like I said, this connection is very important. Oh wow, that's a lot. Almost there. Oh. Okay, 75 Newton meters, whatever. So use the same tool to hold this thing steady. Tighten the crank nut to 50 Newton meters. Wow. You know what? I may need to use the penny method on this guy. So the other way to do this is with jamming a penny right here in between the gears, okay? Since this nut here, I should be able to do it. Because using the tool, it's actually, I can feel the springs in there moving while I'm tightening it. So I probably won't be able to tighten it properly like that. So this is the other way to do it, the getaway. Get yourself a penny. And if this will work for your standard clutch basket, standard clutch, you jam it right here to tighten, actually, either one, this nut or this nut, okay? But with this setup, I had to get the right tool. So you can do that, and then I will tighten the crank nut to 50 Newton meters. Okay. So it'll deform the penny because it's soft and it won't damage the gears. Okay, so this thing is done. So this is locked down. You have to bend one of these tabs or this lock washer, one of the sides of it. Bend it against the nut so it won't back out. So I'll show you how to do that. It's just simply tapping. Okay, like that. All right. So 50 Newton meters, 70 Newton meters. Okay, Loctite and wave washer. All right, now I'm going to show you how to actually install the clutch plates. Okay, so before I show you how to compress the springs and this plate, so you can load in the clutch discs or plates, you need to double check this guy right here, the center, this pressure plate. It comes like this. Okay, so put this thing in first. And push the pressure plate against that plate and make sure it's not touching the actual clutch nut on the other side. You can tell it's not touching because I can move the center. Okay, it's not popping it out. So yeah, check that because I mean, I'm using E-Gig parts, so they should work together flawlessly. But, okay, as I said, this is actually E-Gig one finger clutch. It comes with 8 springs. Okay, so you put all 8 springs in there. Obviously the pull is going to be harder, but it can handle more power. So if you're doing some monster build, I think 8 springs, you can handle almost 40 horsepower. But on a smaller build like this, 136, you should be able to get away with just 6 springs, which is good for what, 25 horsepower, I think is what he said. And then of course, if your motor only puts out 15 horsepower, you can use 4 springs. So I will do 6 because that's what I have in my blue badge, and the clutch pull is still really easy. So, as I said, this is good for up to 25 horsepower, which should be plenty for most setups. So 6 springs should look like that, okay? So when you place this thing in there, as I said earlier, you have to assemble this guy in the case. You can't just assemble the outside and then install like your standard clutch, okay? So once you have this guy, usually you if you want to, you can get this proper tool, and I'll show you what it does. So this guy threads onto the inner part of the clutch basket like a clutch puller, okay? And then I thread this guy on, and it compresses the springs and allows me to put the plates in, okay? If you don't have this tool, you can use a standard small frame clutch puller with I guess a piece of pipe and a washer, okay? Acts the same way. It's just a cheaper version. You probably get it a lot quicker than ordering the special tool. So I'll show you how this guy works. So you would thread in the puller like you were to pull the clutch first, okay? And then you need a spacer like this to go around the puller, okay? After that, you have the nut and a washer. This does the same thing. So you tighten the bolt, and it'll actually compress the springs. And then again, you can load the plates in after that. So that's if you don't have the right tool or the expensive tool. I have it, so I'm gonna be using this. So first thing I'm gonna do is tighten this guy on. Good. Then the sleeve goes over that, and you tighten the bolt. Okay. As I said, this is actually what is compressing the springs down, so you can load the plates in. Just like that. Okay, everything's holding together. See how the springs are compressed right now? Now I can actually load in the clutch. Now I'm just showing you how this is done. I'm actually going to remove these and soak them in oil overnight. So the E-Gate clutch comes already stacked up, so don't take it apart unless you know how it goes back together, okay? So cork first, I think. Cork first, plate. Cork. And this special plate that has the little prongs facing inward, little teeth facing inward. Another cork. Sometimes these you may need to trim some material off just so they fit properly, but most of these seem to be going in okay. It's just very tight. There you go. Plate with the teeth facing inward. I don't know if you can see that. Okay, same thing. Again, this is how it came. I stacked this in this order, so I'm just putting them back in this order. If you're using the same clutch and you mix them up, make sure you go on E-Gate's website and see how they go back on. So same thing, teeth facing inward or bent inward. Cork. And then the plate, the end plate. Perfect. And then of course the retaining ring. Okay, now that's all assembled in there. As you saw, you can remove this, and that's it. You're done with the clutch. Of course, you need to put the pressure plate back on. But again, I'm gonna take this apart again. I'm gonna soak the corks overnight, and then we'll fully assemble them tomorrow. Okay, so I have the clutch plates out, and they're soaking in oil right now. So a couple of things you need to get along with this case, because it comes stripped. This case vent up here, you got to order one of these. Okay, on the bottom side, you got to order 2 cable adjusters that look like this. Okay, these go here. Okay, and you got to order some drain plugs as well. Rick has opted to go with these nice GS drain plugs. So yeah, I'll put some new gaskets on them, and we'll install those real quick. You want to put the drain plug in there, because once you soak the clutch in oil, it'll slowly come out and it'll drain out of the case if you don't put the plug in. And the last thing I want to do is torque the Kickstarter down. I think this is 23 Newton meters, 14 millimeter bolt. All right, I got the Kickstarter torqued down, cable adjusters installed, and also my drain plugs installed. So yeah, now I'll reinstall the clutch, and then we'll move on to the clutch cover. Now that I have the clutch fully installed with the cork plates that I had sitting overnight in 30 weight non-detergent oil, I can go ahead and reinstall this pressure plate. Okay, this is just simply pushing this guy on like this. Okay, push that on, make sure the center bearing is still moving around freely. That way you know it's not touching the input shaft or the nut behind it. Okay, so this is good to go. Now, this is an E-gig 1-finger clutch, meaning you're supposed to be able to pull it with 1 finger. But that's only if you had 6 springs in there, like I have it now, rather than 8 springs. Obviously, more springs, more resistance, so you might need to use 2 or 3 fingers. But it will not do it on its own. You have to get one of these guys. So, I know this looks like a standard clutch cover, but it's not. This is an XL2 clutch cover. Main difference between this and your standard one is that there's a bearing on the end here, and the shaft here is also has splines on it. So you can actually move this around and adjust this little thing if you wanted to. You get more pull or less pull or whatever. So the operation on these guys is a lot smoother compared to your factory clutch cover. The other major thing is that this is already machined right here and here, okay? Because some of the primaries, the aftermarket ones, stick out further. So if you go and use your factory clutch cover, this actually might touch the primary. So you'll have to grind this out. The other thing is, I've seen people do is put a spacer here to space the clutch cover out. Now, when you do that, the more you space this out, the more chances it's going to hit the brake plate back here. Okay, like this. Okay, I think this one might be okay. Yeah, this one seems to be okay. Not really touching it. Actually, it's starting to touch it. But yeah, it should be okay with the gaskets and whatnot in there. So on my blue badge, I actually had to modify this. I got a different clutch cover. I think I got the Crimaz one. It's not as flat here. Okay, so I had to actually grind some material off the back here for it to fit. Okay, another thing you got to keep in mind with the clutch covers is that you need to set this little arm here at an angle like this, okay, rather than straight on 90 degrees with the case. Okay, you set it like this so you get more of a clutch pull. Okay, this is what E-gig actually recommends. And now you may think that you can shift gears with this thing set to wherever, but if you have a hard time getting it back into neutral, that means you don't have enough clutch pull and the clutch is not fully disengaged. Okay, so keep that in mind. So the other thing is nice that Rick got was this thing here, which I mentioned earlier. So this guy here is actually a cable adjuster that moves around. So wherever you set this this arm, this will kind of follow it. Okay. The ones that don't move, you would have to bend the bracket to kind of straighten the cable wherever you decide to set this angle, okay? So yeah, that's pretty much all the little issues that you may or may not run to on your small frame build. I have ran into every single one of these issues because I've built a couple of these. And yeah, hopefully this video is going to help you if you decide to build one of these motors. All right, so I'm going to leave this off for now. I'll go ahead and put the cylinder and the piston and all that stuff on, and then I'll make sure everything still cycles freely, and then I'll assemble the rest of this stuff. Okay, so for the cylinder, Rick has decided to reuse a Melosi 136 kit that he had laying around. I don't blame him. These motors are expensive, so anywhere you can save some money is a good thing. So I've cleaned up most of these surfaces. Everything seems to be okay here and here. I also went and made sure these ports weren't razor sharp. If they are razor sharp, they actually feel like they're gonna cut your finger when you rub your fingers over them. Make sure you take a like a little Dremel tool and kind of smooth these little edges out, because if you don't, what happens is that these rings get caught up on those edges, and then it actually leads to premature wear and tear. So yeah, definitely something you should consider doing if you are installing a brand new cylinder. Okay, so the Melosi 136 kit actually has the ability to use a reed valve setup instead, which is what this plate is. Okay, so if you were to remove this and get the actual reed valve setup, and then that setup actually comes with a cap to close this off here. With a reed valve setup, you get a little more power. I really don't think it's that much more power, because I have it in my blue badge right there. Okay, Orangina is not running that. Orangina is running the regular rotary pad setup, rotary valve setup, and you've seen the video of how good that runs. The thing about the Melosi reed valve setup is that there's a design flaw in it, and the manifold that comes with it is set up in an angle, or is set up to where the bottom has a little area where fuel pulls up. So usually this is sitting on the bike like this. Okay, manifold comes out and goes through the frame here, and there's a little area right here on the manifold that likes to pull with fuel. Okay, so when you have the bike idling for a second, fuel just continues to pull right there, and then as soon as you actually wrap the throttle to go, all that fuel gets sent into the cylinder, and it kind of floods it out and dies. So if you have that set up, you have to sit there and keep feathering the throttle a little bit, you know, to just so the fuel doesn't pull up there. It's a design flaw that I saw, or that people have told me about, and I'm not sure if they fixed that issue or not, but that's one of those issues with the reed valve setup, if you were wondering. Okay, so I have that on my blue badge, and I am using the regular rotary valve setup on Orangina. So I mean, you've seen the way she runs. The blue badge is a little quicker, but I don't know. It's just a give and take thing. If you want absolute most power you can get out of the cylinder, you do need to go to the reed valve, but then you need to worry about the fuel pulling issue, unless they fixed it, which I'm not sure. So all right, now I've explained all that, we can go ahead and install this thing. Now, when you go and install a used cylinder onto a new case, make sure you get a new gasket kit, okay? This is the Melosi gasket kit. It comes with all your gaskets and whatnot. I'm still going to use Yamabond 4 on all the surfaces between, on both sides of the gaskets and whatnot. That way I know it's a nice, good seal, okay? All right, with all that being said, let's get to it. All right, so the gasket kit actually came with a new gasket for this reed valve port. Okay, I've taken this off, and I'm going to put Yamabond 4 on both these surfaces before I reassemble this thing, because Rick does not live down the street from me, so I don't want any air leak problems, and so this is going to take me literally 2 minutes to do. I'll make sure everything's good here before I send it back to him. All right. That's that. All right, that's good. Leave that alone. Okay, so next up we'll go ahead and install the case studs. Now, The case does not come with the case studs, so you need to order the right case studs for your setup. I think anything over 50 cc's require the longer case studs. Okay, so when you go install the studs, you'll notice that on the stud there's less thread here, more thread here. Okay, the more thread part goes into the case. All right, you need to leave about 120 millimeters of length sticking out of the case. Okay, so I'm gonna go ahead and put some Loctite on these ends here. That way you can stay there, not back out. Let me see here. Loctite. Again, 120 millimeters, which is close enough, whatever. About right there. All right, do the same thing for all four. Okay, now I have all my case studs installed into the case, 120 millimeters length sticking out of them. I'll install the piston next. So on the piston, the small frame pistons, okay, there is an arrow, which is right there. Okay, arrow there. Okay, now on the small frame, the exhaust points up and back and down. All right, on a large frame, they point down. So make sure this is in the right orientation. Okay, so on this piston, you get two circlips like this, okay? Now you see there's an opening here. On the piston, there's an opening there. Make sure you don't put in the circlip where the opening matches up with the opening on the circlip, okay? A lot of piston manufacturers tell you not to do that because this can move and, I don't know, pop out of there. I don't know, but just tell you not to do that. So do the opening on the circlip this almost 180 degrees from the opening on the piston. All right, so I already got this one in there. That was actually a bit of a pain. I have my wrist pin on the other side, so my wrist pin puller tool right here, and then on the rod itself I put the wrist pin bearing. I coated it in 2-stroke oil. That's good to go. So now we'll install the piston onto the rod. Now remember, arrow points up on a small frame, like this, okay? Set that there for now. Set this guy up real quick. And we'll install the wrist pin into the wrist pin bearing. All right, so when you're doing this, make sure the wrist pin is actually going into the wrist pin bearing, not all caddy in there, so you're not crushing it. So if you actually have it lined up, it's really easy to install the wrist pin. Okay, that's it. All right, see on the wrist pin here, it's actually bottomed out against the circlip. So now I'll go on the other side and install the other circlip, and this should be done. All right, now onto the other side to this circlip. These circlips are actually a pain in the butt to get on, so be patient and you'll eventually get it. Try not to use tools that bend the circlip up, okay? So try to be as cautious as you can, and eventually you'll get it in there. Okay, I got it in there. That was actually a bit of a pain. So yeah, like I said, be patient, and you'll get it in there eventually. Just make sure that circlip is actually in the groove in there, okay? Not sitting on the outside. Double check, triple check. All right, if that falls out while the engine's revving up, you're gonna have a really bad day. Okay, so this is done. I'll slip the cylinder over. After of course, I put the Yamabond 4 on this gasket surface here and a new gasket. All right, I have Yamabond 4 on both sides of the gasket. I'll go ahead and slip this over the piston. I do Yamabond 4 on all my base gaskets. Just something that I do, because that one time I didn't do it, it leaked right at the base. So totally up to you whether you want to do it or not. But I always do it on mine. Okay, it's all the way down, I think. Everything's matched up. All right, do a little bit of cleaning up on the threads, and then we'll slip the cylinder on. All right, so on the piston itself, there's a little pin that sticks out right there. That's actually where the ring gap will sit. Okay, there, and over here, there's one. I'm not gonna check the ring gap because this is a used cylinder, and I'm sure Rick already ran it and everything was fine. So, all right, now that I got that all situated, I'll slip the cylinder over. Before I do so, I'm going to put some 2-stroke oil into the cylinder. Coat the inside here. It'll help with the startup and installation and whatnot, so nothing gets caught when I slip the rings into here and the piston and whatnot. Okay, that's good. Slip this guy over, make sure my ring gap is where the pin is on the piston. Hopefully you can see what I'm doing, but double check. Okay, good. Slip right on. Now I've got the cylinder on. Make sure this thing functions properly. So, you kick it, obviously it's going to move the cylinder up and down, and then when you release, you hear those clicks for it to reset. Okay. All right. So now I'm going to put the cylinder head on. Cylinder head actually has an O-ring here. I went in and put some 2-stroke oil on there, just because it was really dry, and if it's dry, it's not going to kind of expand correctly when you actually tighten it down. Okay, so got that done. That's good to go. Now, when you put this on, make sure the spark plug hole is facing you. All right, like this. Well, sort of like you. Okay. Now, if you want to double check which way it should be, grab your cylinder cover and put that on. You'll see the hole lines up, and then you know it's correct. All right, so now I'm gonna go ahead and put the hardware on here, and then I'll torque the cylinder head down properly. I'm gonna use brand new hardware, washers, lock washers, and M7 nuts. Okay, so washer, lock washer, yep. All right, new M7, all new hardware. Okay, now I'll torque this thing down. Okay, so onto the fly size seal. As I mentioned earlier in the video, this is actually a 20mm taper crank. Okay, the seal is different from your standard 19mm taper crank. Make sure you order the right one. Here's the specs right there, 20 by 32 by 7, and that's the model number if you want to order these. I think Dave at Mercado keeps these in stock, so reach out to him if you need one of these for your upgraded crank setup. Okay, so I'll go ahead and install this thing, and of course I'm going to put some oil on the lips and actually on the crank. All right, it's good to go. Usually you can just push this thing on, but sometimes you're gonna knock it in with a socket or something. All right, I found like a little, this is actually part of my blind bearing puller tool, but it fits perfectly. If you're gonna use a socket, make sure the other end where you connect the socket is not too small and is touching the threads on the crank, okay? So yeah, this is nice and hollow, I made sure. So yeah, now we can just tap this guy on gently. Okay, we got the seal completely in there. Well, not all the way in, but yeah, it looks perfect. Actually, nice and even all the way around, just so you know that is a good seal. So, cycle the crank a little bit, make sure everything's good, and yeah, we should be good. Rick has decided to go with a Melosi 25mm PHBL carburetor. So it comes as a kit, all right, with a manifold and everything. Has a little velocity stack. So here's the manifold, and I guess at Melosi they don't talk to each other. So the cylinder designer did not talk to the intake manifold designer, and these things don't actually fit together without modification. Okay, I think this is a little too low, and the holes are not lining up. I think we're off by maybe 2 millimeters. All right, it's either I grind this down a little bit or I grind the plate down a little bit so that this can go further up. So I can actually bolt to the case. So I know I already put the cap on there for the reed valve, but yeah, we're gonna have to take that off and do it again. Yeah, it's one of these things that we run into building these small frame motors. Just too much stuff crammed in such a small space, and sometimes you gotta modify them. So I actually had to modify the plate up here, and also had to modify the intake manifold down here. And now they actually kind of line up, and I can actually bolt it all together. All right, so I've got my gasket on there with the Yamabond 4 on one side. I got Yamabond 4 on the manifold. So the hardware comes with it. Actually doesn't come with lock washers or washers. I don't know why they cheap out on stuff like that, but if you don't have it, make sure you put some Loctite on these threads. So, all right, I got that all situated. I'll tighten these bolts on. Nice and snug, should be fine. Okay, perfect. All right, guys, I've actually let the Yamabond cure for a couple hours now. So I have my air leak tester hooked up to this thing. This is actually a medical pump, and it reads in minutes of mercury. Okay, so for any two-stroke engine you build, you should do this air leak test, because a two-stroke motor that has an air leak is not going to run right. Period. Won't idle, will have erratic revs, whatever, you name it, it could happen if you have an air leak. So anything I build, always do an air leak test. So this kit I actually got from a scooter shop. I think it was Scooter Swap Shop. And it came with a block-off plate for a Minarelli engine, the exhaust, but the plate works on a small frame. It also comes with this lug here that works with the intake boots. Okay, so I have everything all sealed up. Got the spark plug in here, got the plate on the exhaust, and this plug up here. So next thing I'm gonna do is pump the motor up to 300 minutes of mercury. Okay, 300 minutes of mercury equals about 6 psi. Any more than that, and you might start blowing out the seals. Okay, so right now it seems to be holding a little over 300 minutes of mercury. Now the idea is to have it hold 6 psi, 300 minutes of mercury, for 6 minutes, okay, without any leaks. If it does, then you're good to go. If not, then you have to figure out where your air leak is, okay? This is why I use Yamabond 4 on all the surfaces, because you'll never know where it might actually leak. So I can actually see it drop a little bit right now. It may just be the actual pump itself going to max capacity. So let me see here. I'm gonna let it sit a little longer, and then I'll check to see. Actually, yeah, it's got a pretty good leak. All right, I'm gonna spray the engine with soapy water, and we'll see if I can find the leak. I think I found the leak. It's right here on the top of the intake manifold. I'm guessing I didn't torque these bolts down enough. Or is the fact that the pressure point on the manifold is up here rather than at the base. So, I'm going to take this thing apart. I'm going to apply more Yama Bond. And then I'm going to bolt it all back together. Let it sit for a couple hours. And we'll check again. Alright, so I think I know what the problem was. I didn't grind enough material off the top of this manifold. I guess it was still touching that reed valve plate. And wasn't allowing me to actually bolt it all the way down properly. So obviously it wasn't flat up against the case, and that's why it kind of leaked up here. So I went ahead and grinded down a little more material here. Again, I'm going to apply Yama Bond 4 here, and then there's some on the case already. The gasket in between. Let it sit for a couple hours, and then we'll check it again. Okay, I've got the intake manifold all bolted up. New gaskets, extra Yama Bond 4. I'm gonna let this stuff cure really well before I do another air leak test, but I'm pretty confident I've got the issue resolved. All right, so next up, I'm gonna bolt the clutch cover back on, and there's a gasket that goes in between. Usually I coat these gaskets with grease. It kind of expands them a little bit once you compress them between the two parts, so it helps with sealing. I don't know if it's absolutely necessary, but this is what I like to do. So yeah. All right, there you go. Place that on there. Grease will kind of hold it in place while I bolt it down. So it only goes on one way. Down here is an extra hole. Okay, it matches up with the hole in the case. All right, now that I got the gasket all greased up and in position, I will put the cover on. Make sure all the holes line up. Got new hardware for this. M6x10 hardware. Just make sure you get the right lengths. Alright, I got all the hardware installed. So these four are the same length. The bottom ones are a little longer because of the thickness of the case, the cover, I mean. So I actually have a new snap-on 1/4 inch torque wrench. These are supposed to be 7 Newton meters. So torque these down crisscross until you have them all tight. Use that. Okay, so the case doesn't come with the little studs installed. So they tell you to install these with some Loctite and stick them out 20 millimeters. All right, I'll do that now. Okay, so as for the rear brake plate, there's a couple parts that go onto this before you install it onto the case. Okay, but I'm only gonna temporarily put this on there just to make sure all the fitment is okay. Usually there's a seal that goes right here, like this. That goes on like that. There's a gasket there. So I'm just gonna place this up there for now. I'm gonna show you why in a second. So I'm gonna push it up here, and I can already tell that it's not sitting flat because this is an aftermarket XL2 clutch cover, and it is a little more material there. So we are gonna have to modify this brake plate a little bit. I don't know if you can see, but right there, right here, is touching the cover. There's an indentation for it, but it's not enough. So what I'm going to need to do is grind this nub down a little bit until this brake plate sits flat. And after that, I can actually bolt it on. Yeah, I can already tell that's keeping it from going flush. So you don't want to just go ahead and tighten it on there because you could crack the brake plate. So make sure you pay attention to that if you're going to change the clutch cover. Okay, so now I'm going to grind this little nub off or down right here, and just enough so I can bolt this thing flat. All right, so reason why I'm not actually gonna fully assemble this is because Rick has ordered some parts for me to fabricate. So this is the original brake arm. As you can see, he ordered another one. He wants me to take this guy apart and weld the double loops on the bottom here. Reason being is he wants to be able to use the PK brake cable and adjuster. Looks like this. Brake cable is kind of threaded on the end, goes through here. There's a little nut on the other side, so you can actually fine tune the brake arm. Okay, rather than this old school way, which the cable goes through and you kind of pinch the cable down, bend it over. So it's just a lot easier to adjust with this setup. But unfortunately, I'm gonna have to do some custom as far as welding this stuff together. So I will leave that for the next day I go to work. All right, leave that stuff there for now. I'll modify this brake plate so it actually goes flat against the case, and then we can bolt this on. Okay, so you can see I've grinded down both these nubs here because they're actually both touching. One here, one here. So grinded a good amount of material off. Now I'm gonna test fit it, and hopefully it's enough. Nope, needs a little more. All right, so I think I just ground off a good millimeter or two off both these nubs here, and I think it finally fits. So nice and flat, not touching the cover anymore. These nuts are going to be M8 by 1.25. Get washers and lock washers for this. All right, I'm going to go ahead and push in the rear hub seal, because I'm not going to have to remove this now that I got this stuff grinded down properly. It's not going to send stuff into the seal, so we're good there. The brake arm modification I can do later on, but I just want to show you how this thing goes on. So the seal itself has a spring going in towards the hub. Make sure you put lube on this lip here, that way you can easily press it in there. All right. Little stock is on the same size. Should be good to go. Yep, there you go, just like that. Okay. Push this guy on. Again, M8 by 1.25 nuts, lock washers and washers. Torque spec on these, 17 Newton meters. Okay, I'm going to torque these on, but I'm going to be taking this off again. So 17 Newton meters. All right, that's that. Good to go. Again, I'm going to be taking this off to do the rear brake lever modification, but I just wanted to show you guys how this actually goes together and what you have to do or what you don't have to do. All right, so next up, I'm going to put the hub on there, and then for these newer output shafts, it uses the really big nut that comes on like the EFL transmissions. So I think it's like a 24 millimeter nut, and I'll show you exactly how that works. Okay, so before you actually install the rear hub, make sure you put some oil around this area right here, because this has to go through that seal that's in there. Okay, if you don't put oil there, it's very easy to the hub will catch the lip of the seal and pop that spring out. So like I said, put some oil there before you install this, and push it on as even as you can so you don't mess up that seal. Okay, just like that. This stand is cool and all, but it's not tall enough for me to actually spin this thing. So I'm just going to show you what you need to actually finish this job. So like I said, it uses the EFL mounting hardware. It's a spacer here that goes in first. Okay, after that, big nut like this. I think this is a 24 millimeter. Okay, so I'm just gonna use my impact. It is a 24 millimeter nut. Okay, this torque spec is supposed to be between 59 to 98 newton meters. Yeah, you can't do that unless you have something to hold the hub, or you're sitting on the bike with a tire on there, and then you can actually torque it properly. So I just temporarily put it on my impact gun here. So there's a hole there for a cotter pin. You got to put this little encapsulated castle cover thing on, and the pin will go straight through there, bend it out, and you're good to go. So that's that. Yeah, it's not, the nut is not all the way down, so you can't actually put a cotter pin in there yet. Once you torque it down properly, you should be able to just fine. So that's that. And then you can put the cover on if you want to. So that's it for the hub assembly. So, like I said, this is temporary. I need to pull this back off and do that brake lever modification. So right now, let's go to the other side, and I'll show you what to do with the flywheel. All right, here I have a brand new SIP vape kit. Variable ignition kit, okay, the sport kit. Now, make sure if you order this kit, you order for the right crank, okay? Your stock crank is gonna be 19 millimeter taper. Since this is an aftermarket upgraded crank, it's a 20 millimeter taper. So you gotta make sure you order the right flywheel, which is this guy right here. Make sure it has the right taper in there. This is the right taper, it's 20 millimeters. So yeah, we'll go ahead and bolt the pieces together. All right, so the vape kit comes with the stator actually in the flywheel, well, part of the flywheel. Okay, so pull it out with those little sticker things that are attached to it. Okay, so what you want to do is install this guy onto this plate first. After that, you can run the wires and whatnot and get them to where they gotta go. So this goes on like this. Wires go through the plate. Okay, something like that. Get all that stuff lined up. Screw this guy together. Okay, now I've got the stator mounted onto the stator plate. I'll run the wires through the case. So I usually just run it through this big hole up here, like this. I don't really separate them. So through this big hole, and then the stator plate goes around this nut here. There's a little notch in the plate, goes around the nut. Okay, so I'm gonna use these markings here for timing. I'm gonna use that big mark on the case as center. All right, that way I can advance or retard if I have to. So I'll leave that there like that. The kit comes with these flathead screws with the little beauty ring around them. This is actually what holds the stator plate in place. Okay. Go ahead and put one in there. There's actually 3 that holds it in place. Okay, so right now I'm just going to snug these because you're going to have to loosen them up to either advance or retard the timing. Okay, so once I have that in there. I'm going to put the Woodruff key into the crank. Just like that. Okay. Now, the flywheel, or half the flywheel, looks like this. Okay. This goes on first and the flywheel bolts onto that. So, my recommendation is to leave the flywheel off because it's a lot easier to adjust the timing with just this on there. Okay. And I'll show you why. So, we're going to go ahead and put this in. Okay, that's good. So you can actually still access these screws. All three, actually. So do your timing marks on this guy. I'm gonna go ahead and match it with this big knot, this big mark in the case here. And then we'll set the timing. And then we'll put the flywheel on afterwards, okay? So this is an M12 nut. So you make sure you get an M12 lock washer like that and an M12 nut. All right, it's different from your regular 19 millimeter taper. This 20 millimeter taper uses an M12 nut. The 19 millimeter taper uses an M10. Okay, so make sure you get those parts, stuff that you have to order. All right. Okay, so now that I have this temporarily on there, I'm gonna go ahead and set the timing. So I'm gonna do my best to try to explain how these vape kits work. I could be wrong. I really don't know, to be honest with you. But I've done 2 or 3 of these. And I haven't blown anything up yet, so I think I'm doing okay. All right, so there's 2 versions of this ignition kit. There's a road version and the sport version. So the road version is a static ignition. So on an OC 136, it's supposed to be set to 17 degrees before top dead center. Okay, once you set that up, leave it alone, you're good to go. Now, on the variable version, if I was to set it to minus or 17 degrees before top dead center, you'll see this graph here. It'll be 17 degrees before top dead center right here at around 2000 RPM, like in this range right here. And then when you actually rev it up to like 7000, it actually advances to 5 degrees. So at 7000 RPM, you're going to be at minus or 12 degrees before top dead center, which is way too advanced for the cylinder. And I guess that's when things start going wrong, like melting pistons or what detonation or whatever. So that's assuming that this motor revs with 7,000 RPM. I think it does. Most of these small frames do. I mean, it really depends on the pipe you get. So if your motor revs to 9,000, you would have to retard it even more as the initial setting. Okay. So like I said, I'm gonna assume this revs to 7,000. I'm gonna set the timing at minus 23 degrees at idle. Okay, at idle is like right here. It says 2274 RPM, you're at 0 degrees. So at this RPM, it'll be minus 23. It'll be 23 degrees before top dead center. When I rev it to 7,000 RPM, it'll advance 5 degrees right here. And then it'll be resting at 17 degrees before top dead center, at the top of the rev range. And that's where it's supposed to be set at as far as the MOLO C136 kit. All right, so like I said, I've set all of them up like this. It was either minus 24, minus 25, minus 23 degrees before top dead center. And I had, like I said, I haven't had any issues. So I'm gonna do the same with this. Set it at minus 23 degrees. And then by the time it revs to 7,000 RPM, it should be right at 17 degrees before top dead center. All right, hope that makes sense. If not, I'm sorry. There are a few other videos of people explaining how this thing works. That's just my understanding of it. So take it for what it's worth, I guess. So, all right, I'm gonna set this motor to minus or 23 degrees before top dead center, and I'll leave it at that. If this thing does rev higher than 7,000 RPM, Rick will have to adjust the timing a little bit. All right, then, let's get to it. Fine timing, I'm going to once again be using my Buzzwangle tool. I love this thing because it's universal and it works for a whole bunch of different flywheel setups. Okay, so first thing I'm going to do, screw the piston stop into the spark plug hole until it stops. Like that. Okay, now turn this thing counterclockwise all the way till it stops. Right there. All right, and then this thing, make sure it's level. Tighten the screw in the middle. Like that. Okay, now it's somewhat level. Put the Buzzwangle tool on top. Okay, zero the gauge by hitting that twice. So now it's at 0. Now, once you got that all set up, you want to rotate this flywheel all the way clockwise till it stops. Okay. You're at 56.8. All right, you're going to divide 56.8 by 2. 6.8 divided by 2. 28.4. Okay. So you're going to pull the piston stop out now. Keep rotating the flywheel until it hits 28.4. Okay, this is top dead center. All right, that means the piston is all the way at the top of the stroke. Okay, now at this point, what you want to do is mark top dead center. So let me grab my little marker here. Like I said, I'm going to use the middle as top dead center. This little chunk of material on the case, and then I'm going to mark TDC on the flywheel. Sorry, I'm not going to mark TDC on the flywheel. I'm going to mark TDC on the case. So I'll just remember that's TDC, and then I'll move this thing back and forth to okay, now that it says 28.4, I'm going to mark this to be TDC right here on the case. I picked a bad spot, but you get the idea. TDC. Okay, right there. Okay, that little mark would be TDC. Okay, so what I'm going to do is 0 the gauge now, and then rotate this thing counterclockwise 23 degrees. 23 degrees right there. Yep. Put another mark right here. I'll write 23 degrees. 23 degrees before top dead center. Okay, I can also do another one over here to be 24 or 25, but it's so minuscule that, you know, I think Rick could retard it more if he wanted to, just by turning it maybe just a little bit. And if he needs help with timing stuff, I can also help him as well. So I'll just mark 23 degrees there, which is what I'm going to set this thing to. So now that it is set, now I can actually spin the flywheel and flash the motor at the same time. If these two marks line up, that means I know the timing is right. If this mark is actually forward or is the back, then I'll need to loosen the flywheel and rotate it this way, or retard it or advance it, depending on where this is going to sit once I spin the motor. All right, so TDC 23 degrees before top dead center are the two marks I'll have on here now. Okay, so for me to actually check the timing with the drill gun, I need to have the CDI hooked up, and I need to have these wires hooked up as well. Okay, so the kit actually comes with a wire, spark plug wire that is, but it doesn't come with a spark plug boot, which is strange. I don't know why. The amount of money you pay for these kits, it should come with everything, but it doesn't. So take the spark plug wire out, put this little boot on the end here. So you look at the end of the coil or the CDI, it's there's a screw in there. So you're gonna screw this wire into that screw. Okay, just keep spinning, it'll keep biting into it, and then it'll actually go further into the coil, securing it. I may need to move this boot up a little bit. Okay, keep turning this guy until it goes, threads all the way down and bottoms out. And I think it's there. Okay, so after that, push the boot over the CDI itself. So this is the part that actually determines whether you have a road kit or a sport kit. Okay, static or variable ignition. So you ordered the wrong kit. You could just tell them to send you one of these. It'll change it whether you want static or variable. Okay, so that's good. Now the plug itself, it does not come with, like I said, you need to order one of these. Okay, I usually typically use this one right here. It's an NGK version. That's the model number right there. So first thing I will do is put this little boot over the wire. Probably be a good idea if I actually sprayed some lube on here. So it makes things a little easier. Okay. Put the little boot over the wire first. Okay, I'll put this guy. There on the end of the plug. Then same thing, I'm gonna screw this thing into the wire. Keep turning it till it bottoms out. All right. Push a little boot forward. Okay, so there you go. Now it's all set up, sorta. All right, so this guy, we're gonna bolt on the end of the case here with something like, I just put a screw there to hold it in place. Now there is a ground wire that needs to attach there as well. Now we're going to mount the CDI onto the case. Now there is a special bracket that SIP makes to utilize these two holes in the case. Of course they don't include it with the kit because I like to nickel and dime you for everything, but we'll just attach this temporarily like this. I'm going to put a M4 bolt through this hole. Stick out that side. Now on the wiring coming from the stator, there's a ground here. Okay, so go ahead and ground that with this bolt that you're installing. I have a washer and a nut for the other side. Hopefully you can see what I'm doing. I'm just gonna temporarily install this thing and then check the timing, and if everything's good, we may need to order the SIP bracket that's made for this case. That way we can properly install this CDI. But as for now, this is just for testing. It should be fine. CDI mounted to the case. I got this brown wire coming from the stator, it's grounded right there. So these two wires, it's pretty self-explanatory. It will go to these two wires here. Now the SIP kit comes with this little plug that you install. So let's make sure this plugs in correctly. I think it goes like that. Yep. So the red wire is going to be on the top spot. Put this thing around. Let me see here. Yeah, sideways. Like that. Red wire on the top spot, white wire on the bottom spot. So orient. We'll flip these wires around until they actually go into the connector like that. Okay, once that's done, you can plug this thing together, and that connection's done. Okay, very easy. Red to red, white to white. This is actually your kill switch. Okay, so you have this thing. You're gonna run this all the way to your handlebar switch. That's actually what kills the motor when you push that switch. Okay, but right now you don't need it. We're just trying to see what the timing is on this motor. Now I'm going to try to check for timing. I have my timing light hooked up to the spark plug wire. I have the spark plug grounded to the case. I have all my wires temporarily hooked up. So these are the wires coming from the stator to the CDI, ground wire, and then the 2 wires for the coil or the CDI right here. So now all I need to do is spin the motor and see where it's set right now. So I have my drill hooked up. I'm gonna go. I'm sure you can see that right now it's about 20 or maybe 19 degrees before top dead center. So I'm going to loosen these 3 stator bolts, rotate it back just a tad, flash it again, and see if it's actually at 23 degrees before top dead center. If it is, then we're done. I can put the flywheel on and move on. All right, let's do it again. It's actually almost perfect at 23. I could maybe rotate it counterclockwise just another hair. It'll be actually perfect. So let's do that real quick. All right, let's try again. All right, perfectly set at 23 degrees before top dead center. Okay, recap. So it's set at 23 degrees before top dead center right now. If I start the bike up and actually rev it up to 7,000 RPM, it should advance 5 degrees, putting it at 17 degrees before top dead center at 7,000 RPM. Okay, that's what it should be set at. Like I said, if your motor revs higher than that, you'll have to retard it a little more. If your motor revs lower than that, you'll have to advance it a little more. So you really have to play with it. Okay, now that I have the timing set, I'm going to install this beautiful aluminum flywheel onto the actual flywheel drum. I guess that's what that thing's called. So it's just these little flathead star bolts. They come with Loctite on them already, so I'm just going to snug these up. Don't over tighten these things. I've seen people just shear these things off because they got over tightened. So just a little snug is good. All right. Okay, there you go. I'm gonna check the manual and see if there's actual torque spec for those before I move on. Okay, so the book says 12 to 14 Newton meters, so I'll just do 13 for these flywheel bolts. Okay, like I said, don't just tighten the crap out of these because I've seen them get sheared before. All right, so follow the instructions. You won't run any problems. Tightening them in the star pattern. All right, so now I got the flywheel tightened onto the flywheel drum. I'm going to lock this flywheel so I can tighten the center bolt. All right, so the torque spec is actually 45 to 60 Newton meters. I'll just do 55. Should be fine like that. Got your standard flywheel holding tool for a Vespa. So got that on there. I'll just tighten this guy down to 55 Newton meters. Okay, there you go. That's it. All right, it's all set up, set to 23 degrees before top dead center. Now really all I need to do is put the shrouds on, and this motor is actually done. All right guys, there you have it. A fully assembled Vespa small frame engine. Okay, that was a lot of work. And it took a long time because of parts compatibility, parts availability, and having the right tools and things like that, and of course time. But finally, we have it all done. Okay, this is exactly how it looks, fully assembled. The flywheel cover on, the cylinder shroud, done some wiring management from the coil to the stator. Okay, and of course the spark plug wire is also mounted here. I use a little wiring clamp and I bolted onto this hole here. It seems to work very well. It holds it tight to the motor so it's not flopping around when you're riding. So the other two wires coming from the stator will actually power the bike. You can use the junction block, which mounts here, or not. I don't. I usually just run the two spades from here into the frame, and again, that's how the bike gets power. All right, so I have the carb set up, all bolted up. This is actually a Malossi setup. Okay, it comes with a PHBL 25 velocity stack, the intake manifold, and the boot. Okay, the main jet in this thing is a 90. All right, that's exactly the setup I'm running in Orangina, and if you've watched that video, you see how well it runs. The needle clip, okay, I have it on the highest spot in Orangina. It runs great in this area. I'm not sure about the area that Rick lives in. You may need to mess with that a little bit, but it's usually pretty close the way this setup comes from Malossi. All right, so on the other side, I have everything all bolted up. Over here, as I mentioned, there is a special bracket that they make for this CDI that mounts onto these case holes, but this works okay as well. Rick may want to get the right bracket. It's totally up to him. So the next step really is to put some gear oil in this thing, hook up fuel, install the exhaust, and I'm gonna try to fire this motor up, and I'm gonna somehow, some way try to shift the gears. Okay, if I can do that, great. If not, I'm gonna have to stick this thing into a frame that I have and do a full function check before I send it off to Rick. Okay, it's gonna be really expensive if he has to send this motor back to me because I made a mistake somewhere. All right, so guys, with all that being said, really, if you know any tips and tricks and things like that, or if you think I'm messed up somewhere or I'm doing something completely wrong, feel free to comment down below. I'm always willing to learn. Okay, that's how we can grow the scooter community. Try to help each other out, things like that. So yeah, guys, that's really it for this video. I hope you've enjoyed these videos so far, and if you have, please don't forget to like and subscribe, and I'll catch you all in the next one.